Hello children. Today we are going to see two important derivations. Okay. So already in the previous class we have seen what is a dipole and what is a dipole moment. And also we have seen that around the dipole there will be a strong electric field. Okay. So now what we are going to do is we are going to derive the expression form. The first expression is the electric field intensity at a point on the axial line of the dipole. Axial line of an electric dipole. So this is the electric field intensity at a point on the axial line of an electric dipole. Okay, there is a derivation, important derivation. Sometimes it may be asked for 3 marks, sometimes for 5 marks coupled with numericals. Okay, so now we'll see what is it. So very easy, simple derivation only. See, I have that is a dipole here. This is minus q and this point is A and this is plus q and this point is B. Right. Now you know that this is the line joining the dipole and the center is named as O. Right. What is an axial line? Axial line means along the length of the dipole if you draw a line. Okay. So if you draw a line along the line joining both the charges. So this is what is called the axial line. Okay. So let me even extend this slightly. This is the axial line. So now I am interested in finding out the electric field intensity, okay, at the point that is P. Okay. Now due to this electric dipole, and I think you have an idea, yesterday we have seen this one, this is the length of the dipole, okay, and the point P, okay, is at a distance of, actually see the point P is at a distance R from the center of the dipole. Our point of interest is at a distance R from the center of the dipole. Right. Now what is that? We have to find out the electric field intensity at P due to the dipole. How to find? First we have to find out the electric field intensity at P due to minus Q and then due to plus Q. Okay, then what is the net electric field? Okay, so now first is let E1 is the electric field, therefore the electric field intensity at P due to, okay, minus Q charge, due to charge minus Q, where is it? At A. At A. Okay. Therefore, what is that? That is equal to, that let it be, that is A1. A1, this is magnitude. Okay, that is equal to, you know, 1 by 4 pi. What you have to do for that? You have to keep a unit positive charge at P. When you are keeping a unit positive charge at P, okay, therefore what is the force experienced by a unit positive charge by minus Q, that gives you your electric field at P due to minus Q, correct? What is the electric field? Force experienced by unit positive charge when it is kept at that point. Therefore, keep a unit positive charge at this point. okay, at P. And what will be the force experienced? Force will be an attractive force because it is minus Q, no? You are keeping a unit positive charge at P. It will experience an attractive force due to minus Q at A. Therefore, the force, let it be this, that, to give this is the direction of your A1, correct? This is the direction of A1. Force experienced by a unit positive charge at P will be an attractive, due to minus Q will be an attractive force. Therefore, it will be along PA. It will be along PA. Right. This is the direction. Now, come back to your, what is the magnitude? That is nothing but 1 by 4 pi epsilon naught Q divided by, what is the distance? AP squared. Okay. AP squared. Therefore, what is that? This is equal to 1 by 4 pi epsilon naught Q by the other charge here is unit positive charge, right? Therefore, Q into what is that? Unit positive charge. Therefore, that gives you F by, what is it? Q naught. That is equal to 1 by 4 pi epsilon. On to unit positive charge, instead of unit positive charge, you are keeping a charge that is Q naught. Therefore, F by Q naught, that gives you, what is it? 1 by 4 pi epsilon naught into Q by AP squared. Therefore, here Q, is it clear? Hope you are following me. Okay. Therefore, Q by 4 pi epsilon naught into Q by, what is that? R plus, from the center. Okay. From the center it is, what is the distance? It is R. Okay. And plus A. R plus A the whole squared. Okay. And what is the direction? Along, what is it? PA, na? Along PA. It is attractive, right? Okay. Then, it is the force experienced by a unit positive charge. Okay, due to, what is that? Q. Here, why I have not written minus Q? That minus Q gives you the direction. That is why it is, what is that? It is given along PA, because it is minus only. It experiences an attractive force, PA. That is why magnitude means it is Q divided by 4 pi epsilon naught. Okay. Q see, there is one. Yeah. Okay. Right. So, that is why that is equal to Q by 4 pi epsilon naught. It is 1. Very, very important. Okay. Therefore, Q 1 by 4 pi epsilon naught Q divided by R plus A the whole squared along PA. Okay. Next one is, what is electric field intensity at P due to charge plus Q at, where is it? B. Therefore, that is nothing but A2. A2 magnitude. What is A2 magnitude? First, after that we will go to direction. That is equal to 1 by 4 pi epsilon naught Q by, what is Q by? What is the direction? That is, what is the distance here? BP, na? Plus Q. Plus Q is at B. Therefore, what is the distance of separation between plus Q and P? That is BP squared. BP squared, correct? And that is equal to 1 by 4 pi epsilon naught Q divided by R minus A, na? R minus A the whole squared. So, this magnitude is over. Now, direction. Direction, once again, what you have to do, if I want to find out the the electric field intensity at P due to plus Q at B, what should I do? I have to keep a unit positive charge at P, correct? at P. Therefore, in which direction it will be experiencing a force? It will be experiencing, because it is a unit positive charge. Charge at B is also positive. Therefore, it will experience a repulsive force. Okay, therefore, repulsive force means it will be in this direction. It will be in this direction, right? And what do you say about the magnitude? Can you compare E1 and E2 here? First one is denominator E1 R plus A the whole square. But for E2, other things are same. E2 it is R minus A the whole square. Therefore, definitely you know very well E2 is larger than E1, correct? Okay, therefore that also you have to show in the diagram. How the magnitude means slightly it is more, correct? Hope you are following. Therefore that gives you E2. That gives you E2. Okay, therefore what is the direction? It is along. Okay, let me use the along BP produced. What do you mean by that? BP produced. If you extend BP and that direction will be your E2. Okay. Actually, you are what are you keeping here to find out? It is you are keeping by theoretically you are keeping, what is that? Plus 1 coulomb of charge, unit positive charge there. It is understood now. Okay. Though theoretically I am telling. Practically it is not possible, so you are going to keep a test charge there. Okay, practically. But as we are deriving here, you are assume that you are keeping a unit positive charge there. Therefore, what will be the electric field? Electric field at any point is nothing but force experienced by a unit positive charge when it is kept at that point. Therefore, this is okay, right? But this is not over. What is that? E1, E2 is ready, and the direction also you know. But what is the net field? Okay, therefore you have to find out therefore what is the total field. Okay, the resultant intensity, electric field intensity. Okay, therefore the resultant electric field intensity, let me go to the next slide. Okay, therefore the resultant electric field intensity at P due to the dipole. That is nothing but, what is that? E. Therefore, that E should be equal to, both are here, E1 and E2 are in opposite direction, and you know very well here E2 is more than E1. Therefore, you can say that E2 minus E1. If both are acting the same direction, you have to add. Here both are acting in the opposite direction, of which E2 is more. Therefore, your resultant will be E2 minus E1. Okay, therefore, what is E? E that is equal to, okay, E that is magnitude. Okay, that is equal to, what is that? 1 by 4 pi epsilon naught. Okay, Q by R minus A the whole squared, okay, minus 1 by 4 pi epsilon naught Q by R plus A the whole squared. Okay, that is nothing but Q by 4 pi epsilon naught into 1 by R minus A the whole squared minus 1 by R plus A the whole squared. Fine. Therefore, what is that is equal to Q by 4 pi epsilon naught into R plus A into R minus A. Therefore, R square minus A square the whole square it will be, right? In the denominator, R square minus A square the whole squared. Okay. And what is your this, if you substitute, what is, see, LCM you take, therefore you will be getting here Okay, some things if you expand it, therefore there are so many things this cancel. The final answer will be, what is it, 4 q by 4 pi epsilon naught 4 ar divided by r squared minus a squared. I think you know how to take LCM. Okay, you should know. Okay, therefore the answer will be this. Is it clear? Therefore, but I want to substitute this in terms of dipole moment. What is dipole moment? Dipole moment P, that is equal to Q into 2A. Correct? Therefore, what I am going to do here is Q by 4 pi epsilon naught into, okay, Q into 2A into 2R कर सकते हैं ना, 4AR. Okay, this Q by 2QCR. This can be written as, okay, divided by r squared minus a squared the whole squared. Okay, therefore, what is that? E, that is equal to, okay, 2QA. What is 2QA? 2QA. Wait, I'm thinking. Okay, this 2QA is nothing but P, na? Therefore, I can write this one as P, okay, by 4 pi epsilon naught into 2R by r squared minus a squared the whole squared. Hope you are following. P by 4 pi epsilon naught 2R into r squared minus a squared the whole squared. Okay, right. So, this is about electric field, but electric field is a magnitude. But what is that? Electric field will be, in which direction it will be? Net electric field will be, okay, in the direction of E2. In the direction of E2. What is E2? E2 will be along BP when it is produced. Okay, therefore, here you can say along BP produced. Okay, but what is, okay, fine, BP produced, fine. But now what is the direction of P? Yesterday we have seen what is the direction of dipole moment. Dipole moment will be from minus negative charge to positive charge. Correct? Okay, therefore, B is also negative charge to positive charge, means in which towards right. Correct? Like that, what is electric field intensity direction? That is also towards right. That is along BP when produced. Okay. Therefore, if I want to write the vector form of E, therefore I can even write E, that is equal to vector. That is equal to, it is in the direction of P only now. Therefore, I can write P by 4 pi epsilon naught into 2R by r squared minus a squared the whole squared. Here there is no need for you to write along and all. It is very well understood. E and P are in the same direction. Here I have written them in terms of only magnitude. That time I am writing magnitude as well as along BP produced. But here this is enough. This gives you the what is that final expression in the vector notation. Okay, P divided by 4 pi epsilon naught 2R by r squared minus a squared the whole squared. Right? Right. Next one, let's see. Therefore, let me take if, okay, if the dipole is short dipole, in that case, your length of the dipole, okay, is very much less than the distance of the point from the center. Our distance of our point P from the center. Okay, therefore in that case, what will be E? Therefore, E can be written as P by 4 pi epsilon naught 2R. Okay, Here r squared minus a squared the whole squared. No, is better. What is that? A is very much smaller than r. Therefore, a can be neglected. Therefore, is it clear? R squared minus a squared the whole squared. That can be written as a, because in comparison a is very much small when compared to r. Na? Therefore, you will be getting here r power 4. Therefore, okay. Therefore, what you will be getting here, it is r power 4. Therefore, what is the final expression for E in this case? Only for short dipole I am telling. Okay, that is equal to, you can say it is 2p by 4 pi epsilon naught into r cube. This will go now. It is 4. Hope you are following. I am. After that, Shivani will ask, what, madam? You have, what is that? You have striken both r power 4 fully. No, I am not. Okay, it is only 4. Okay, so I have to be very careful. Okay, very good. You are following the lesson now. That itself I am very happy. 2p divided by 4 pi epsilon naught r cube. Okay, so now the direction of E, what is the direction of E? Is nothing but along BP produced, right? Therefore, clearly shows that for a given dipole, okay, your E is inversely proportional to r cube. Na? All the other factors are constant. Therefore, it is inversely proportional to r cube. Hope you are following this. Okay. So, this is about E, that is equal to P by 4 pi epsilon naught r cube. Okay. That